This is the 10th session on Newton's laws of motion. This is in continuation of the 9th session. Okay. So in this also I'll take a problem, numerical problem on Newton's laws of motion. Okay. Integration based problem. Okay, fine. I'll write down the question. Okay. See, question is this. See, two blocks B1 and B2 of masses M and 2M are initially placed at rest over a smooth horizontal surface. They are joined to each other by a massless spring of force constant K and of natural length L. Okay, fine. The spring is initially relaxed. A constant rightward force F begins to act on the lighter block. From t equal to 0, find the elongation of the spring at time t. Of the spring at time t in terms of F, M and K. Of F, K and M. Okay. This is the required question. Okay. Fine. What I do, I write this one. Okay. So see, this is the solution. I write down the solution. I give the solution. First, I draw the initial diagram. This is a smooth horizontal surface on which the two blocks are free to move. This is the heavier block B2 of mass 2m. This is a spring. This is the lighter block M1 B1 of mass m. This spring has a force constant K. Initially, it is said to be relaxed, given to be relaxed. Let us assume that natural length of the spring is L. L has not been given. I have assumed it on my own. And now initially both these blocks are at rest. This is the diagram at time 0, as I mentioned just now. Now constant rightward force F begins to act on the block B1 in rightward direction. F constant. Now when we apply this force, the blocks will begin to move. Let us assume that we have taken now to find the elongation of spring at time t. What we have to do is first we have set up the Newton's laws of motion equation for both the blocks and then solve the resulting differential equation to get the elongation of the spring at time t. To get the elongation of the spring at time what? T. Alright. So, to solve the problem I set up a convenient coordinate system. See, question answer has nothing to do with the coordinate system. Coordinate system is just meant to carry out the calculation. Alright. So, I draw the diagram here. It's like this, see. I take this origin somewhere here, okay. Origin has coordinate system is attached to ground, okay. This line of motion is the x-axis, and this line of motion is the y-axis. Okay, this is the situation at time 0. T seconds later, this block will have moved some right side. This block will also have moved some right side. So at t time later, I draw the fresh diagram. This block has come somewhere here. This block has come somewhere here. But I show this in next row. Okay. So this 2m and this is m. Here F is acting. Okay. Now spring has been elongated to the same amount. Suppose the length of spring at this instant is r, say. Okay, fine. And the natural length of the spring is L. Okay. This is the coordinate system. This is the origin. This is the line of motion x-axis. Coordinate, let x coordinate of 2m be x. Okay. Let x be the x coordinate of 2m. Okay. And fine. Now what I do, I draw the free body diagram of both the blocks in ground frame. Alright. So what forces act on this block of mass m? mg, normal force n1 and force F. Also we have assumed that spring is elongated. The elongated spring will exert a force in this one direction, and magnitude of this force will be k times elongation of the spring. Epsilon is the elongation of the spring. What is elongation of the spring? Length of the spring minus its natural length. So elongation of the spring is equal to r minus L. That is the elongation of the spring. Okay. So this is the free body diagram of block of mass m, vector block, at time t. This time 0 is for this one. For this is just an equation at time t. Now I draw the free body of 2m at time t. Again in ground frame, inertial frame. Which forces act on 2m? 2mg, n2. And this spring is elongated. This elongated spring exerts a rightward force on the block. That force again becomes k times epsilon. Where epsilon is the elongation of the spring. Epsilon is just equal to r minus L. Okay. Now what I do? I apply Newton's second law to 2m in rightward direction. So what is the x coordinate of 2m? X. So I apply Newton's second law to 2m in rightward direction. So what do I get? 2m d2x by dt2 equal to net force on 2m in rightward direction. Now f dash is what? I write it like this: fx1 dash minus fx2 dash fx1 double dash. What is fx1 dash? Sum of x components of all the real forces on 2m which make acute angle with positive x-axis. There is only one force, k epsilon cos 0 degree. So this becomes how much? K epsilon. What is fx double dash? That is the sum of x components of all the real forces on block which make obtuse angle with rightward x-axis. There is no such force on 2m which makes obtuse angle with rightward x-axis. So this term becomes 0. So we get 2m. This you must be sure how I have written this term. This is nothing but the x component of acceleration of 2m at time t. It is simply d2x by dt2 from the theory of particle kinematics. So 2m d2x by dt2 is equal to k times r minus L. This is the first equation which I obtained. Now what I do, I apply Newton's second law to block of mass m in rightward direction with respect to ground. So what do I do for that? This I just do it fx2 minus fx2 dash, because this block b2, so I write it 2. Okay, index I change it. Now I apply Newton's second law to block of mass m in rightward direction. So what is the x coordinate of block of mass m? It is x plus r. So what do we write? M times d2 by dt2 into x plus r, because x coordinate of block of mass m becomes x plus r. So second derivative of this, that is the x component of acceleration of block of mass m. That is again equal to fx1 dash minus fx1 double dash. This will be written as m d2x by dt2 plus m d2r by dt2 is equal to fx1 dash minus fx1 double dash. Now what is fx1 dash? Sum of x components of those forces on m which make acute angle with positive x-axis. There is only one such force, F, which makes 0 degree with positive x-axis. So fx1 dash becomes F cos 0 degree, that is simply F, minus fx1 double dash. What is fx1 double dash? It is sum of x components of sum of magnitudes of x components of those forces which make obtuse angle with positive x-axis. There is only one such force which makes obtuse angle with x-axis, positive x-axis, k epsilon. Magnitude of this component in this direction will be k epsilon cos 0 degree. It is simply how much? K epsilon. Alright, fine. So this is the second equation. Now what I do, I eliminate this quantity from this and this. This equation I divide by 2m. This becomes how much? d2x by dt2 barabar k by 2m into r minus l. And this what I do, this also I divide by m. d2x by dt2 plus d2r by dt2 is equal to f by m minus k epsilon by m. Alright. Now what I do, from this and this equation I eliminate this d2x by dt2, that I eliminate. Alright. So this I substitute in this one. So I rub this one, okay, fine. So I replace this d2x dt2 here in this one. So what do we get? I get this one I replace by this in this equation. So what do we get then? We get d2r by dt2 plus d2x by dt2 becomes k by 2m r minus l, that is equals to f by m minus k epsilon by m. Epsilon is as usual r minus l. So this I write like this: d2r by dt2 plus kr by 2m minus kl by 2m is equal to f by m minus k by m r minus l. Alright. This also I rub it now. So now kr by m I bring it this side and kl by 2m I shift to that side. So it becomes d2r by dt2 plus kr by 2m. kr by m I bring on this sides plus kr by m barabar f by m. kl by m this side it becomes 3 kl by 2m. Alright, fine. Is it alright? Now I rub this one, alright. So this equation becomes what? This becomes d2r by dt2 plus 3kr by 2m barabar f by m plus 3kl by 2m. This is the differential equation R, okay. Now 3k by 2m is a positive quantity, so let 3k by 2m be equal to omega square say. So we get d2r by dt2 plus omega square r is just equal to f by m omega square l. 3k by 2m becomes omega square l. Now see, this is a second order differential equation with r as a dependent variable and tan t as a dependent variable and with constant coefficients, okay, linear second order differential equation with t as the independent variable, r as the dependent variable. From theory of second order differential equation, solution of this equation will be written as a1 cos omega t plus a2 sin omega t. Let's call this right quantity as constant. This quantity is alpha, which is a constant quantity, plus alpha by omega square. Okay, these are here a1 a2 are constants. They have to be determined from some given condition. All right. I rub this one, alright. So this is simplify now. So R becomes a1 cos omega t plus a2 sin omega t, and alpha by omega square. Alpha is what? This quantity is alpha, right side. This quantity is alpha. Alpha by omega square becomes what? F by m plus 3kl by 2m, 3kl by 2m upon 3k by 2m. So this becomes R is equal to a1 cos omega t, a2 sin omega t plus 3k by 2m goes away, L remains plus 2f by 3k. Okay. This is the expression r in terms of time t. But now we have to determine r, we must know a1, a2. Alright. A1, a2 we have to determine, then only we can solve this question. I wrote this one, alright. So this means we get this r is equal to L plus 2f by 3k plus a1 cos omega t plus a2 sine omega t. Alright. Now a1, a2 are constants. Now they have to be determined from some given condition. R is the length of spring at arbitrary instant t. At t equal to 0, the spring is relaxed. That meaning R is just equal to L. So at t equal to 0, we put R equal to L. L plus 2f by 3k plus a1 cos 0 omega into 0 0 plus a2 sin 0. a2 sin 0 becomes 0. L also L goes away. Cos 0 becomes 1. a1 becomes minus 2f by 3k. Alright. So a1 I have determined. Now we also have to find the value of a2. Alright. I have this one. Okay. Now see one more thing. At arbitrary instant t, what is the x coordinate of 2m? X. So velocity of 2m is say v2 at time t. That is simply dx by dt from theory of particle kinematics along one dimension. And what is the x coordinate of block m at time t? X plus r. So velocity of that block is v1 say. That is equal to d by dt of x plus r. X plus r. That becomes dx by dt plus dr by dt. Now see, if we divide this, we subtract this to dx by dt goes away. So v1 minus v2 becomes dx by dt plus dr by dt minus dx by dt. This two term goes away. v1 minus v2 becomes dr by dt. Okay. Now see, at time 0, both the blocks are at rest. So at time 0, v1 is 0, v2 is also 0. So at time 0, dr by dt is also 0. So using this additional condition, we can determine the value of a2. Alright. So v1 minus v2 is dr minus dt. Is it alright? Fine. This I'll not write as actually it's alright. Fine. Now what I do out of this one? So at time 0, what is time 0? What we first find the expression for dr by dt. So how much is dr by dt? Derivative of r with respect to time. These two are constants, so derivative goes away. This becomes what? Minus a1 omega sin omega t a2 omega cos of omega t. Now at time 0, v1 is also 0, v2 is also 0. So time 0, dr by dt is also 0. So this is substitute t equal to 0 and dr by dt 0. Minus a1 omega sin 0 plus a2 omega cos 0. Sin 0 becomes 0. So 0 becomes a2 omega, cos 0 becomes 1. So a2 becomes what? 0. So a2 goes away. Alright. Now substitute this a2 in this equation. This one. Okay. Set up this one now. So a1 becomes this. Now we substitute a1 there. And a2 is 0. So what do we get? R is equal to L plus 2f by 3k. a1 becomes this. Substitute a1 here. Minus 2f by 3k cos omega t. And a2 becomes 0. That term goes away. So elongation of spring at time t is simply r minus L. That becomes 2f by 3k 1 minus cos of omega t. Okay, this is the expression for elongation of the spring at time small t. Is therefore the required answer. I hope it is clear. Fine. So this type of question you must know how to solve, especially the second order linear differential equation with constant coefficients, whose solution I have written here general form. Okay, so this must know it, because such questions have been asked in JEE Advanced. 2016 they gave a question on second order differential equation. Okay. It was a full 8 marks question, 2 marks, 4 marks, two questions, 4 marks each. So you must definitely know how to set up such class of second order differential equations. Alright. Now in this I take up one more video on this second session, 10th session. Okay. I love this one. ठीक है. I take a one more question of this session. Okay. See, question is this: a small block of mass m is thrown vertically upward from ground with initial speed of 20 meter per second. Apart from weight of the object of the block, a resistive force F equal to kV acts on it. Where K is a positive constant and V is the instantaneous speed of the block. Instantaneous speed of the block. Okay. This rule is valid both for upward and downward motion of the block. The block returns to its initial location with a downward speed of 16 meter per second. Okay. Question is, find the total time of journey of the point, journey of the block. Take G to be equal to 10 meter per second square. Okay, this is the required question. Fine. You rub this one. Okay. Projected with 20 and returns to how much? 16. G is 10. Okay. Now question is how to solve this type of problem. Okay. How to solve such questions is the problem. So what we do first? We first draw the diagram of the situation. Okay. So this is the ground level. Block is thrown here from ground in upward direction with initial speed of 20 meter per second. As it moves upward, because of gravity, is slowed down. And apart from its weight, a resistive force acts on it, kV, where K is a positive constant and V is the instantaneous speed of the block. This resistive force acts on the block in downward direction. So what happens? As it moves up, its speed goes on decreasing. At certain instant t, when it reaches its maximum height, its speed is 0. Suppose it attains a maximum height of h, where its speed instantaneously becomes 0. And suppose it takes t1 time to move from here to here. t1 is the time of upward journey. When it comes here, it begins to move down. And when it reaches here, its speed has decreased to 16 meter per second. And in downward journey, suppose it takes a time t2. So what is the total time of journey of the block? Total time of journey of the block is t, say, that is just equal to t1 plus t2. So total time of journey of the block is t1 plus t2, where t1 is the time for upward journey and t2 is the time for downward journey. Now question is how to find this t1 and t2. Okay, and g we have to take it to be 10 meter per second square. G, this data we have to take. So now what do? We set up the Newton's second law equation of the block during its upward journey separately and during its downward journey separately. Okay, so what first I do? I consider the upward journey of the particle, upward journey. I consider the upward journey of this block, upward journey. Upward journey of the block. This has been thrown here from say t equal to 0. Suppose it reaches here at t equal to say capital T naught. T naught is the time taken by the block to reach its highest point. In upward journey, we are considering its motion for time t lying between 0 to T naught. Okay. So we take some arbitrary time lying in this interval. Suppose the block is say here. At that time, we draw its free body. mg is acting downward direction. It has upward speed v and resistance force kv acts in downward direction. Okay. I apply Newton's second law to this object in upward y direction. Say, I have taken upward direction to be the y-axis. What will just leave it? I just apply Newton's second law to block in upward direction. So now what we write? A net force in upward direction means what? F dash minus F double dash is equals to m times acceleration in upward direction, say ay. Okay. Now what is F dash? F dash is the sum of all the components of those forces on the block in upward direction which make acute angle with upward direction. There is no such force. This becomes 0. And F double dash is what? Sum of the sum of all the magnitudes of all the vertical forces on the block which make obtuse angle with a positive upward direction. Only two forces act which make obtuse angle, that is kV and mg. Both make 180 degree from upward direction. So magnitude of these components becomes how much? kV plus mg, plus mg. Okay. Also at this instant velocity is v. It has moved the shear distance y from ground. So this becomes dv by dt. Okay. Now this becomes minus, v will written as dy by dt. V is just from the straight line theory. V is just equal to what? Dy by dt. So minus k, v becomes dy by dt. Minus mg barabar m dv by dt. Okay. Now what I do with dt, I multiply on both sides. Minus k dy minus mg dt is equal to m dv. Now what I do, I integrate this equation on both sides. So initial speed was v naught, how much? 20 meter per second. At its highest point, its speed becomes 0. At in the limit of t is 0 to t1. Initially y is 0 and upper limit y is maximum height h. Okay. So this I integrate now. What do we get? Minus kh minus mg is constant, comes outside. So minus mg integral dt 0 to t1 becomes simply t1. This m comes outside. M integral dv v naught 20 to 0, that becomes minus 20. So minus sign goes away. kh plus mg t1 is equal to 20m. Okay. So kh plus mg t1 is equal to how much? 20m. This is the first equation. Okay. Now what we do now? Now we consider the downward journey of the point. We now consider the downward journey of the moving object. Okay. So this I rub it. Okay, fine. Suppose the downward journey starts from here. Downward journey. Downward journey of the block. So in downward journey, what I do, let this be the highest point at the object, highest location of the block from where downward journey begins. So I take this to be y-axis, and initially this is the origin. If it is released from here, it begins to move down. Suppose t seconds later, after starting from here, t seconds later, object is here. It's moving in y direction. Okay, and this is the y component of its displacement y. Okay. Now I draw its free body at that instant. So what are the forces acting? One mg, and since it is moving downward, it will exert resistance force in upward direction. How much force will act in upward direction? kV. Now apply Newton's second law to this object in downward direction. So what do I write? M dv by dt becomes f dash minus f double dash. Now what is f dash? F dash is the sum of all the components of forces on the block in downward direction which make acute angle with downward direction. There is only one such force mg which makes 0 degree. So f dash becomes mg cos 0 degree, that is simply mg. And what is f double dash? F double dash is the sum of magnitudes of components of all the forces on block in downward direction which make obtuse angle with downward direction. There is only one such force kV which makes 180 degree angle with downward direction. So f double dash becomes kV cos 0 degree. So magnitude of that component, that becomes kV. Okay. Now what I do, this I write in this way, m dv by dt, mg minus, again v becomes what? dy by dt. Alright, fine. Alright. This one I rub, okay. See, this equation right here because it will be used. I'll write it here and rub it. Okay. KH plus mgt1 equal to 20 and this is the first equation. Okay, fine. So this is the equation. So minus this also goes away. This also I'll rub it. Okay. Now what I do, I multiply this by dt again. mdv equal to mg dt minus k dy. Now what I do, I integrate this equation again. Integral, this becomes mg integral dt minus k dy. What is the limit of y? Y starts from here. And maximum y is what? H. H is the maximum height attained by the block from ground. In downward journey, it moves the distance h before hitting the ground. Time t limit 0 to t2. T2 is the time of descent of the block. V is initially 0 and its lowest point its speed becomes 16. So now this when integrated, we get 16 m is equal to mgt2 minus kh. K is constant, comes outside. Integral dy 0 to h becomes h. So second equation becomes 16 m is equal to mgt2 minus kh. This is the second equation. Now if we add these two equations, kh will go away. First and second equation when added, what do we get? kh and kh goes away. What do we get? mg into t1 plus t2 is equal to 36m. M and m will go away. Total time of journey is t1 plus t2, which is t, say, which we have said initially. That becomes 36 by g. And g becomes how much? G becomes 10. So 36 by g this becomes. So this becomes 3.6 seconds. 3.6 seconds is therefore the required answer. Okay. So this is the total time of motion of the block during its entire course of journey. So total time of motion of block becomes 3.6 seconds. This is therefore the required answer. Alright. This also I have explained. So this was the total now 10 videos on Newton's laws of motion have been made. And last 2 videos also based on numerical problems. Okay, so you go through these all examples solved properly. And if you have any doubt, you write the doubt in the comment box. I'll look into it and rectify it. Okay. So if you understand these questions and then take up numerical from any other source, I'm sure you'll be able to solve most of them. You will not have any difficulty. Okay. So close it here. Fine.